Most often, a field is a special kind of matter that exists around something. For example, as we remember, an electric field is a special kind of matter that exists around a conductor. So, if you take a closer look beyond this model in educational textbooks, you will discover that the physics of fields is actually much deeper and more complex than we initially think or perceive at first glance. In reality, it is important to remember that all particles are, in one way or another, vibrations of fields, that fields are interconnected with each other, that fields have the ability to transmit energy to each other, and that objects and numerous other things can be created from fields. There are a lot of interesting things happening with fields in physics. Each interaction has its own field. There exists a gravitational field that is not completely described. There exists an electric field that is also not completely described. There is an electromagnetic field, a magnetic field, a temperature field. So what exactly is a field? A field is a specific volumetric spatial characteristic that enables you to determine particular values at every individual point within this field. What is a temperature field? We have a room here, and in different points of the room there are different temperatures. If we attempt to create a graph representing the distribution of point values and temperature within this room, it becomes evident that we have effectively built a field. From a physical and mathematical perspective, a field is precisely the kind of thing it is defined to be. A field is a set of certain characteristics that describe a particular phenomenon. What is the field itself? Well, we will not philosophize excessively at this moment, but in this particular context, it is easiest to perceive a field as a type of auxiliary, physical, or even possibly mathematical model that is capable of describing the phenomenon being studied. So it turns out that an electric field is a specific model that enables the measurement of the intensity of this field at every point and the creation of a visually stunning graph. Temperature field is a model that enables the measurement of temperature at each point in the room and also facilitates the creation of some kind of graph or visualization, and so on and so forth. The same can be said about each field, and as we have already mentioned, fields exist everywhere. In cosmic vacuum there are actually fields too, there is a field. And because this is a mathematical model, the field differs there only in the sense that the field has zero characteristics at these particular points. Therefore the cosmic vacuum, therefore any vacuum, is always permeated by fields. So, why is a radio wave transmitted in space? Not simply because there should be an electromagnetic field around certain objects, but where it is absent, something magical and fantastic happens there. Oh no! Any field is just a grid that enables you to build a specific characteristic or attribute in a structured manner, providing a framework for organizing and manipulating data effectively. And where it might seem that there shouldn't be an electromagnetic field, those very guiding principles still exist, along which, roughly speaking, a radio wave can be launched. That's why a radio wave easily passes through cosmic vacuum.